I'm going to share the question with you all. Okay, can you all see this?
Yes, sir.
Right. So the question is, they have given a part of holiday file, right? Holiday file in the sense they have given a part of a database, right? So in this database, it contains a booking number, meals, nights, hotel, and the price. So this is the part of the database table you have, right? And they have also given something else. Below, they have given this information. The following codes represent the meals, right? So for meals, they have given a specific code, RO for room only, BB for bed and breakfast, HB for half board, FB for full board, and likewise. Okay. So is it clear? This part is it clear? Hmm? Huh? Is it clear?
Yes, sir.
So answer me, yeah? Otherwise I won't continue. Right. Okay. Then they have given the first question. Complete the tables below to show the data type and field size for each field. Complete the table below to show the data type and field size for each field. So they have given the field names. What you need to do is you need to give the data type and the field size. So for the time being, we will ignore this particular one, field size, because we have not done this part so far, right? Field size. So field size, of course, there are it is in the database properties, but we are not going to talk about this in this case, right? So what we are going to do is we will go ahead with the data type. So the booking number. So according to the booking database table, what is the data type of the booking number? Hmm? Huh?
Text?
Text.
Yes.
So why do you think it is a text?
Letters both.
Huh?
Because there are letters and numbers both.
Yes. So you have both letters here and as well as you have numbers here. So it contains both letters and numbers. So it's a text field. This kind of field are known as alphanumeric fields. Can you remember the term? Alphanumeric. Alphanumeric means it has both text and numbers. Right. Then the second one, meals. This one. What is the data type of this particular field? Meals.
Symbol? It's in a symbol form.
Symbol form. Is it?
No, it's in the this access. Isn't there something like short text or something? I forgot the name of it.
Just text. It is also text because it has only text values. Okay.
Okay.
RO, FB, HB, BB, all are text values. So it is also text.
Okay.
Okay. So for booking number, we have text, and meals also we have text, right? Then we have nights. So number of nights the guest staying in the hotel. What is the data type of nights? What? Is it text? What is the data type? Data type of nights should be number because those are numerical values, right? Number, right? Then we have the fourth field, hotel. What is the data type of the fourth field? Hotel.
Text.
Again, text. Why? Yeah, text. It is also containing text values. So it is also text. Then final one, price. 250, 400, 350,
Currency.
375, 295. Yes. Now, the price should be currency. Right? So those are the data types you have in this particular database table. Is it clear?
Yes, sir.
Right. Then
Yes.
the second part of the question. They ask us, state 2 reasons why the meals data have been coded. Now they have entered meals data as coded, like short form. Instead of having the full name, they have used some codes. Why they asked why they have used codes instead of the full name. 2 reasons.
Excuse me, sir. I have
Yes.
one reason. I think this is a bit simple. Sometimes
Okay.
in these companies, they don't like other people checking and reading what is this about. So they
Mhm.
like code it to avoid other people knowing, but only a set of people can understand what it is.
That is one way of looking at it. But in this case, that's not the case situation.
So the text is too long. That's why.
Exactly. Text is too long, right? And it takes some time to enter, right? When there's a data entry operator who's meddling with the system, he or she has to spend a lot of time to type in these values, right? So it takes time, right? That is why they have used coded text instead of using the full name, right? That is one reason, right? Because text is too long, right?
Sir, can we even use that it will overtake the space, because since the text is too long, the field that field will get a bit enlarged.
Bit enlarged. So how you translate that is actually it takes space,
Yes.
right? Space in the sense bitwise.
Yes.
Okay, bitwise, because each and every letter uses a bit, right? Each and every letter use a bit in the database storage. So to minimize that, minimize the usage of storage space, they have used this method. Is it clear?
Yes, sir.
Okay. To reduce the storage.
The storage.
Space taken. We have 2 reasons. Text is too long. So to prevent the time taken to enter date values, and to reduce the storage space taken by these values. So we have 2 reasons, right? Then suggest 2 more fields that could be used in this file. So what you need to do is, now you have to suggest 2 more fields that can be included in this particular table. Can you?
Number.
Huh?
The room number. Room number.
Room number. Very good. Okay.
So isn't it the booking number?
The name of guest.
Hang on. 1 second. 1 second. What? Booking number is already given. Booking number is what? Huh?
Date of booking?
Correct.
The name
Date.
of
Name of the customer?
Yes. Name of the guest. What else? Date departed. Right. What else?
the location of the hotel.
Location of the. Oh, you mean the address? Okay, you can use that. Anything else?
Sir, the number of days the customer is staying.
It's there. It's already nights. See,
Nice.
nights in the sense you can convert it into days, right?
Okay.
So these are some of the extra fields you can include in this particular database segment. So now is it easy?
Yes.
Yes,
What do you
sir.
think? Yeah.
It's easy.
So it's easy, right? Yeah. For your information, this one is also from an oral paper.
So why is the O-level that easy? All of us are thinking that is going to be extremely difficult.
Well, for the starters, if you don't have the logic, it will be difficult for you. So what
Okay.
you need to do, what you need is, of course, your thinking power, right?
We
And
have A plus
the
The sound
huh?
is coming.
What sound?
Yes, sir.
Like-
Whenever you're speaking, like drrrr noise is coming.
Yes. Drilling
Oh.
noise.
Had a logic gate question. Here you are. This particular one, right? This is again from from 2014 November ICT paper, right? So this is another question that they got in year 2014, right? So look at this particular logic circuit. Complete the truth table for the following logic circuit. Can you do this one?
I
Hmm?
can't remember.
Huh? Do you want
Okay.
working in the sense now you need to draw the extra columns that required to complete the truth table and finally find the value of x over here. Can you do this one? Or shall we do it together?
Do it. Let's
You-
do it.
We will do it together.
You are going to do it, or all of us were going to do it? What is it?
Sir, we will
Together.
all will
Separate wise or group wise?
together.
Okay, we'll do
Together.
it together.
All together,
Right.
sir.
Okay, fine.
Once and for
Right.
all.
Then now first thing you need to do is you need to break this into small pieces. That's number one, right? Otherwise this becomes confusing and difficult. So what we have here is we have 1, 2, 3, 4, and 5 separate gates in this particular circuit, right? So this one, A and B, goes through this particular gate. What is this particular gate over here?
It's a O gate.
It's an O gate, yes? And the second one over here,
And
B
gate.
and C, goes through an AND gate. Yes, correct. And this one, triangle, what is this?
Not gate.
A NOT gate, and this one also a NOT gate. And the last one,
No gate.
the last one.
No gate.
No,
It's not a NOT gate. It's a
it's
not.
an AND gate.
It's and not.
Yes.
Yeah.
And gate.
NAND gate. Not and goes together becomes a NAND gate, right? So now you know the gates. Okay, so let's find out the outputs from each and every gate separately. Okay, so first one, A and B goes through first O gate. What will be the output?
What, sir?
Sir, first we have to know whether it's a 1 or a 0.
No, that's not our intent. We need to find the first output. A and B goes through O gate. Then what will become?
A
What
and
is the output? A and B?
uh,
What is the operation of the O gate?
your gate, if there's only one even, it can work.
Yes, but my question is, what is the operation of the O gate? Is it addition? Is it subtraction? Is it multiplication? Is it division? What is it? What is it?
addition?
It's addition, yes. In OR gate, all inputs will be added to get the output, right? So in this case, A and B goes through OR gate and becomes A plus B. Okay? It becomes A plus B. Okay, that's done. Then second half, we have this B input, this fellow over here, goes through this AND gate along with the C over here. So what is the output there? B and C goes through this AND gate. What is the output from this AND gate?
B times C.
B
B,
times C.
Times
B times C. So how do we write it? B dot
B C. B dot C.
B dot C or B C, right? Done. Then next step, we'll move into the top output, first output from the OR gate. This A plus B goes through NOT gate. What happens?
they turn into no.
A plus B will become inverted.
Yes.
Inverted. So
Inverted
A plus B. Huh?
A
How do we write?
minus
No, A plus B. How do we indicate the inversion?
a minus sign.
B.
No,
A
not the minus
minus
sign.
B. B plus
No.
C.
A plus B, we draw a bar on top. Like this. A plus B bar. You can't remember, it seems. Huh?
Sir.
Huh? None of you can remember these things now. Right. A plus B becomes, when it inverts, becomes A plus B bar. Okay. Then focus your attention onto B dot C. What happens when it comes through NOT gate?
B dot C bar.
B dot C
Bar.
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 B dot C bar. Right. Done. So we are nearly there. Right. So we got A plus B bar and B dot C bar. Now these two outputs again goes through this final NAND gate. Now what happens? Now what happens? Right? So we have A plus B bar and B dot C bar. What happens now? Correct. A plus
A plus B bar dot plus C.
Yeah. So what I'm going to do is I will separate these two outputs so it can be identified. I identified easier, right? And B dot C. Both should be inverted, right? Because they went through these NOT gates. So A plus B bar is there.
Sir,
And we have B
when
C
we are
bar.
drawing a bar, if the
Mhm.
both have bars, should we need to draw only one bar for
Yes.
both?
Yes. One bar for both. If they went through separately, you have to draw them separately. Okay. Right. So now we have drawn A plus B bar and B dot C bar together. But NAND is also an inversion, right? So what happens? Both of these are inverted together like this. So this is the final output of this particular circuit diagram. Is it clear?
Yes, sir.
Okay. Right. So what is the final output? A plus B bar dot B plus C B dot C bar inverted, right? So right, this is the final output of the circuit diagram. Right. Now what you need to do is you need to construct this particular truth table to match the output from the diagram. Can you do that? Right? So we are going to follow the same steps which we used here in deciphering the circuit diagram. That is what we are going to do. Okay. So what is the first column then you need to draw over here? Now remember the values were already given. ABC input values were already given. What is the first column that you need to draw?
The
You have two options. One option is you can draw all these outputs separately. A plus B, B dot C, then A plus B bar, B dot C bar, likewise. Or else you can go straight for these ones, inversions, A plus B bar and B dot C bar. Which one would you prefer? Tell me.
In
Which
the
one would you prefer? Okay, you would like to go for the inversion.
Yes.
That means it, okay. Then we'll do that. Fine. So first one is A plus B bar, and the second one is B dot C bar, right? These two. Okay. So I'm going to separate the table like this. Done. Okay. Now what you need to do is you need to complete these two columns. A plus B. So how do you complete this column? How to complete the column? Now we have values for A and values for B in these two columns. Okay. Now what you need to do is first you add these two values, A plus B. Now this value of A here in the first row is 0. Value of B in the first row is also 0. So 0 plus 0 becomes
0.
Becomes 0. Once it was inverted, now because since A plus B inversion, what happens? Once the 0 is inverted, it becomes
1.
It becomes 1. Done. Second row, A0, B0, A plus 0 plus 0, 0, inverted becomes what? Inversion 1. Third row, A0, B1, 0 plus 1,
1.
1 inverted.
When
One
inverted 0.
becomes
0.
0. Yes. Okay. Fourth row also the same, right? 0.
Yes.
Right.
Yes.
Fifth row, A1, B0. 1 plus 0, 1. Inverted becomes
0.
0. Okay. Next one. A1, B0. 1 plus 0, 1.
1.
Inverted becomes
Inverted 0.
0. Okay. 1 plus 1. Binary.
1.
1. Inverted
0.
0. Sorry. Then the last one also 1 plus 1, 1. Inverted
0.
becomes
0.
Right.
Then
So,
that means 1 1 0 0 0 0 0.
yes. Now goes for the B column. Sorry, B dot C bar column. Right. So where we are going to take columns B and C. Right.
Sir,
Values.
we should multiply, right?
Huh? What?
We should multiply, right?
Yes, you should multiply. Right. So we are going to take the values from column B's and column C. Right. So let's go. First row, B0, C0. 0 into 0?
times 0, then inverted 1.
0. Inverted
inverted
becomes
One.
1. Right? Okay. Then B0, C1. 0 into 1?
1. No, 0.
0.
0.
Inverted.
Then
Now
equal 1.
1. Okay. Then we have B1, C0. 1 into 0?
1 times 0 is 0. Inverted 1.
Inverted 1. Okay. Then we have the next
1
fourth
times
row. 1 into
1
1.
times 1 is 1. Inverted 0.
0.
1 times 1
Yes.
is 1. Inverted 0.
0. Then next
0.
one.
0 times 0 is 0. Inverted 1.
1.
1. Correct.
1 times
Okay.
0 is 0. Inverted 1.
Inverted 1. Correct. This one. 0 into 0. What happens?
What's that?
0 into 0.
0. 0 into 0, 0, then 1.
1. And the last row. 1 into 0. 0.
0,
Inverted
0.
1. Okay. That's done. So our first two columns now finished. Okay. Clear? Is it clear?
Yes.
Right. So I'm gonna finish the column. Done. Right. So now we are moving into our final objective, which is now these A plus B bar and B dot C bar goes through this NAND gate. So what we are going to do is, first we will calculate these two values goes through AND gate, right? Before we invert the values, we will first find out what happens when these two values goes through an AND gate, right? So what I'm going to do is, right, I will use this as this one, right? We will go like this, right? A plus B bar dot B dot C bar. Now we will find the
You should
values.
multiply, right?
Yes, we have to multiply, right? A plus B bar and B dot C bar. First, we will find the output of this combination, right?
1 times 1 is 1.
Oh,
Inverted.
Now, how do you get the values for these two? Now we have already found out the values for these two, right? A plus B bar is
Yes.
there. B dot C bar is already there. Okay, let's find out. Now, A plus B bar 1, B dot C bar 1. 1 into 1?
1, then inverted 0.
No. Wait. There's no inversion. There's no inversion there. Just 1. Okay. Right. Next row. Go ahead.
1. That also 1. 1 into 1,
Yes.
1.
1 into 1, 1.
1. Then third row.
0 into 1,
0.
0.
0.
0 into
Yes.
1, 0.
Yes. Fourth row.
0
0
into 1, 0.
0. Yes. Fifth row.
0 into 1, 0.
0. Sixth row.
0 into 1, 0.
0. Seventh row.
0.
0. And the last row also
0.
0. Now what happens is value of x. Now we need to find the value of x. Now here we have already find the output for x, which is inversion of this particular value, a plus b bar dot b dot c bar, isn't it?
Yes, sir.
Yes. Right. Now what happens? What are the values of x then? If we need to invert the values of a plus b bar and b dot c. What happens then? X
0.
1 becomes 0.
0, 0, 1, 1, 1.
Exactly. 0, 0, 1,
1,
1. Sorry.
1.
1.
1,
Here also 1.
1,
Again 1,
1,
1, and
and at
1.
last also 1.
Final one also 1. Is it clear?
So because of the inversion, right?
Because of the inversion which you have over here at the end.
Sir,
This one.
when
This
there is
inversion.
A plus B and B dot C without the
Mhm.
bar, even if we have to calculate, we should invert, right?
If there's no bar, you can't invert. If there's bar only, you will invert the values. Okay? Bar means inversion.
So then why didn't you invert that in the working? There is bar, right?
So
A
these
plus
two.
B bar.
So where's the bar, top bar? There's no top bar over here. I didn't draw that. Right? So there's no top bar. So that top bar goes for the value of x. Oh, right over here. Right? This one. See? This is where you have the whole thing inverted. Right? So for the sake of calculation, we have break this into 2 steps. That's what we have done here. Okay? Is it clear?
Yes, sir.
Right. So this is a logic gate from 2014. Okay? Right. So here's another question they have given, redraw. So I'm not going to give these to you, right? So these are type of questions you will be getting during your exam. Okay, right. I thought of switching back to normal writing paper. So you need to develop construct a logic circuit by using an expression given to you, right? For example, let's say something like this. So I will take a simple one, okay? We have an expression, say,
A sound coming.
not from my end, okay?
Like a radio.
So we have an expression, let's say x equals to a dot b plus b dot, say b plus c, something like this, okay? So we have this expression, logical expression. So what you need to do is, first thing, step number 1, you need to figure out what are the logic gates that is included in this particular expression. How to do that, right? So what you need to do is you need to break this one, right? Number 1, first you consider the a dot b one expression. So a dot b dot means what is it?
It's an AND gate.
It's an AND gate, right? Dot indicates an AND gate. Then we have the b plus c component.
It's an OR gate.
It is an OR gate. Then both of these components go through another what? This plus
OR
sign
gate.
indicates another OR gate.
gate.
So how many OR gates? Yeah, OR gate. How many OR gates should be there?
Two.
2.
Two and
Two separate
one
OR gates
and
and
gate.
one AND gate. Okay, so it's simple, right? So first, let's say we have A, we have B, and the third input is C. Okay, so first A dot B. What is the gate?
AND gate.
And gate.
AND gate. A dot B means it's an AND gate. Okay, done. Then we have B plus C, right? So we have B goes like this and C is over here, and it becomes an
OR gate.
OR gate because it's addition. Done. Finally, both A dot B and B plus C goes through what? This plus sign indicates another
O gate.
OR gate. Simple. Right? Done. Here is our final OR gate. Done. And this is X. Finished. That is how you construct a logic circuit. Is it difficult?
No, sir.
No, that's simple. Right. Okay. Okay, so that's it. That is how you construct a truth table, a logic circuit, and answer a database question. Are there any questions?
Sir, how to find the value of a separate letter like A? How can we find